We're going to look at reading the schematics for the can crusher. One of the first things you want to be able to do is, like in the lower corner here, we're going to take a look at the title sheet. And this title block shows us the panel layout. We see the size of the drawing and the date. But mostly we want to know this description right here. And on this panel, you see it's showing us physical attributes where the e-stop is the DC power, the wire routing. Here we can see terminal block 1. The relays are mounted here in their numbers, as well as the DCVs that are controlling that. So these allow us a good chance to really be able to work with that. So if we want to go in and look at something, we can look at that and see, yep, those are the relays, and these are the exact numbers that we're going to have. So it gives us an orientation to where that is for us to work with. The next page of the print shows the same thing for the mechanics panel of where you'll be doing checks. It's a little bit smaller, and we'll see there's a terminal block 3. And again, when you're making that, we're going to reference these numbers when we're in the schematics coming up. As we pull up the electrical, this print is the power and e-stop. We're going to look at this in a little more detail. And if we take it and kind of look at a section at a time, we can see that there is power up here in L1. L2, also called neutral, that their power, this is a terminal block. It goes to fuse number 1, and it provides power to the conveyor motor. So it's an AC motor that is running and controlled by this relay CR2. How are the connections made? Well, one side of CR2, pin 9, goes to the fuse. Pin 5, the other side of the normally open contact, goes to terminal block 1, pin 37, which then goes to terminal block 3, then 23, which that's where the motor connects to. Then it goes to 24, and back to 39 of terminal block 1 to get power. So these are the places we would be checking with our meter to see what we can find as we look at these things. The next part we see is the e-stop circuit. It has a reset, a seal in, and a relay contact, so it'll self-seal when it's in. And those are used a little bit later as we go down here, as we look at the DC power supply. We can see that the DC supply is powered by L1 in neutral, and it outputs wires called 1D1 and D2. D2 is the minus supply, and plus is the positive, so a 0 to 24 volt supply out of fuse, and this provides our power called 1D1. However, there's an e-stop contact that if that e-stop is energized, it'll break power going to here. And it controls basically the outputs of the PLC that we want to de-energize anytime there is a power shift. Okay, so that we have some sort of reason we want to stop the system. And so that's called 2D1 and 1D1. D2 is our return. So 1D1 is on all the time. 2D1 is only on if we're not in an e-stop. So if we go back up here, right, if this relay has never been energized, then the normally opens are open contacts. Therefore, we'd have power to some things and not to all. So that covers the mechanical and the AC power. DC, be aware of settings for your voltmeter. Now we see a print that just shows how the PLC, HMI, and the Ethernet switch gets its power, and where they're connected, and what they're connected to. Now we see an input module, and that's something to note that as we look at this PLC module, if it's PLC 0, the addresses are 0 through 7 or 8, whichever it is. We have a picture of it down there. Then the addressing is straight across. But here we have the inputs drawn. We'll kind of take a look here for a moment. And we'll zoom in. And we can see that X1 goes to terminal block 3-1. The CAN sensor, the grip arm extender, these are all the feedbacks of the system that tell us where there's power. We see the type of PLC here in wiring just as a reference. Continuing down, we then see we have an output module, and it has the different addresses that it connects to, and it's coming straight off the PLC. So earlier we saw the conveyor motor worked with CR2. Here we see that's actually Y1, and we could check here for power, or check here, or somewhere wherever the contacts are for CR2. The next modules are similar. They provide us with this module has inputs and outputs, but it's being used here as an input module and is handling some e-stop and a pressure switch that tells if their can crusher has enough pressure to crush a can. Then there's another one with stack lights that are providing an output module to be able to turn on the lights if we're in e-stop, if crush is present, activate, if the vacuum cup, all these type of things are able to be monitored on the stack light on the system. Then the relay contacts go to different solenoids to activate the air system of pneumatics. And that concludes that part as far as what we're going to see in troubleshooting. So here we have the module that shows how we're going to take 2D1 power, assuming we're not in e-stop. Then if CR3 is turned on, the arm will rotate. In CR3, we have to do a little cross-referencing, is controlled, we're just going to go up here for a little bit, by CR3, which is Y2. So when Y2 turns on, the arm will rotate, because that relay will be made. As we go back down here, which will close this contact, provide power to the arm rotate solenoid. So the question we have to ask is, if something doesn't happen, where would we put our test points? It's wherever we're going to have a terminal strip that we can get to and be able to troubleshoot those. So here we can test it at the terminal block, be able to see if there's power there, see if there's power at the PLC, standard troubleshooting procedures. So just a quick overview of reading these prints for the can crusher system.